Welcome to the Deep Dive. Today we're really getting into something fascinating, this global push in industry for, better sustainability and efficiency. We hear a lot about Industry 4.0, but now there's this evolution, Industry 5.0. It's about bringing the human element back, integrating our skills with really advanced tech. So, okay, let's unpack this. We're looking at an incredible system designed to achieve something called Zero Defect Manufacturing, ZDM, right?
Exactly, ZDM. The idea is basically flawless components right from the start.
Trying to cut down on failures, reduce waste. It sounds fundamental.
It absolutely is. And the mission here, what we're looking at is how a specific system, a collaborative robotic quality inspection setup, uses things like artificial vision, AI decision-making to hit those EDM goals. And importantly, what that means for efficiency, yes, but also for the people, for worker safety.
Okay, let's get into the nuts and bolts of this system. What are the key pieces? You mentioned robotics, so there's a manipulator robot, I assume.
That's right. A manipulator, an industrial camera for the vision part, and then an AI IoT node. That's like the brain doing the quality control. It often uses a segmentation algorithm, something sophisticated like YOLO V10.
Okay, manipulator, camera, AI node. What else? Human operator involved.
Definitely a human operator. And crucially, for safety and moving things around, an autonomous mobile robot.
An AMR.
An AMR. Got it. So how do all these different parts talk to each other?
That's where it gets interesting. They're interconnected using protocols like MQTT and ROS2.
ROS2. Pronounced ROS2, right? Not ROS2.
Exactly, ROS2. It's essentially a framework that lets all these different pieces, the camera, the robot arm, the autonomous mobile robot, coordinate smoothly.
Because like a common language for the robots.
Precisely. It allows for that seamless operation, which is, vital.
Okay, so walk us through the process. A part comes down the line. What happens?
Right. So the manipulator picks up the piece, then it presents it to the camera.
For the visual inspection. Yep. The camera captures the image, sends that data straight to the AI IoT node.
And the AI figures out if it's good or bad.
It's a bit more nuanced. It uses machine learning to classify defects. Critically, it distinguishes between defects that are, say, correctable, like a small scratch maybe, and ones that aren't, like a crack.
Okay, so it's not just pass-fail. It knows what kind of claim.
Exactly. And that decision dictates the next step. This connects directly to the AMR, the autonomous mobile robot.
So the AI tells the AMR where to take the part.
Precisely. If the AI says perfect, the AMR takes it to the warehouse. If it says non-correctable defect, straight to waste.
And if it's correctable?
Then the AMR takes it back into the manufacturing process for remanufacturing. That dynamic navigation from the AMR adds a ton of flexibility.
That's really smart. It closes the loop automatically.
It keeps things moving efficiently.
And this isn't just a concept, right? You mentioned a pilot line.
Right.
Where they make envelopes for structural isolation. That sounds specific.
Yes, exactly. And the results from that pilot line, well, they're really interesting. They showed significant improvement.
Okay, let's hear them. What improved?
Well, obviously improvements in quality control, which led directly to a reduction in waste. That's a big one for ZDM.
Makes sense. Less waste, better efficiency.
Enhanced operational efficiency overall, yes. But what really stands out, connecting back to that Industry 5.0 human-centric idea, is a reduction in operator physical workload.
How much of a reduction?
For those pieces needing remanufacturing, the ones the AMR brings back, the operator's physical workload dropped quite a bit. It went from about 14.5% down to roughly 8.7%.
Wow, that's substantial. Almost halved.
It is, and this really raises an important point, The high accuracy of these inspection algorithms doesn't just improve piece classification and push towards zero defects. It fundamentally changes the operator's job. Less physical strain means they can focus on higher value tasks. Oversight, problem solving, maybe improving the process itself.
So it's empowering the human worker, not replacing them.
That's the core idea, yes, using technology to augment human capability.
Okay, so wrapping this up, what's the big takeaway for our listeners tracking these kinds of advancements? We've seen AI, machine vision, autonomous robots, AMR specifically, all working together seamlessly in this ZDM strategy. Better quality, better safety.
It really demonstrates successful human-robot collaboration in action. And it prompts a bigger thought, doesn't it? Think about how these kinds of advancements, this sophisticated decision-making and collaboration, could reshape entire industries, not just one production line. What happens when preventing defects becomes the norm and human ingenuity is directed towards, innovation and more complex challenges?
It really does make you think about the future of manufacturing. and that evolving relationship between people and smarter, more capable technology.
Yeah.
It's less about automation versus humans and more about automation with humans.